Hi there, my name is Michael Best. I work as a researcher with NOKIA in Canada, Ontario, Canada. Today we're going to be looking at a bit of a slide deck as well as a demonstration of the XOS ECORD VnoD project, and in particular the NOKIA contribution to that project. So the goal is really to provide everybody a design overview of how this thing works, and also some concrete view as well through the demonstration of actually seeing it work and how to make it work. So making a few assumptions here. There's a familiarity that the audience has of ECORD. There's also familiarity with the VnoD project, which may be a little bit of a stretch, and we'll have a slide to sort of go over this really quick in the next, just in a minute. And then also just general familiarity with CORD. Okay, so what is VnoD? So VnoD is a system of XOS-based control plane services in both the eCORD and CORD local areas. And the system uses a combination of top-down and bottom-up service interactions in the control plane to enable end-to-end networks in the data plane. So if you look at this blue box in the middle here, it kind of highlights this graphically. Try to show that this is an interaction, as a distributed system with components on both the eCORD and at the CORD local level. Okay, I just have a little diagram here. It's not going to go into this details, a lot of numbers and the interfaces and stuff like this on this diagram, but you can come back and look at it later if you need to. This is the system we're working with. As 3 stacks of SDM on the bottom end, as we're using this MiniNet test tool on the bottom end for our SDN networking. And then there's a ONOS controller at the middle part of the stack, and then the XOS, which is the control plane software, or the top part of the control plane software at the top. Okay, so really there's kind of an arch here network in the data plane. It's very simple. We have these MiniNet cords, which represent the local CORD sites, and then we have an eCORD in the middle that's sort of binding it together with one region with 2 sort of central offices feeding into it in our simple little test setup. And so I'm going to give a little demo fast forward. I think it's kind of interesting at this point to sort of show where we're going to go at this point, because I think that's not a bad way to look at it. So from a control plane view, what we're going to end up is something like this. At the CORD 1 and CORD 2 levels, which is the central office, so sort of the localized levels, we're going to have these Pseudowire control plane services, which are controlling and owning this thing called a VnoD local, which we'll get into in a second. So there's 2 of those, one on each CORD site. And then there's the eCORD level. So at the regional level, we have the VnoD global service, which is in control of an E-line service at the control plane level. Okay, in the data plane, I've got this kind of goofy looking orange line through this from end to end. Really, this is what we're going to be doing. So we see a 3-segment network. We have our CORD sites, our local CORD sites on the left side and the right side, and we have 2 hosts in each one of those things, 10.0.0.3 and 10.0.0.6. And in the middle we have our eCORD level, which is kind of this binding level, which is going to pull the whole thing together. So we're going to have a multi-segment network with 2 pseudowires on the endpoints and a MEP line in the middle. And together it's going to create an end-to-end packet flow, and we'll just show that with the ICMP a bit later. Okay, so we're going to go through the steps now. And so I have some slides here, so I'm going to kind of walk through it visually in the slides. I'm going to drop into my command tool and the web GUI to actually show the real world as well. So from the slides, wrong way. We're going to go in step 1. What you do is you go to eCORD and you create what's called a VnoD global service. So you need to tell it about a service handle, which is this global unique identifier that we use for the service. You need to tell it about what kind of binding service you're going to use at the eCORD level. We support right now E-line, E-tree, and E-LAN, only layer 2 services for now. And then you need to tell it the array of intended CORD sites. So this could be, N if you're doing an E-LAN. I think our demo today will just do an E-line, so we're going to do 2 sites, and we'll declare an E-line service here at the VnoD global level. So that's the slide. I'm going to drop into my real world here of VNC and my command tool and web GUI. So on the way by, I'm just going to show you the data plane and what it looks like in real life, and it's really kind of unexciting in a lot of ways. So I've got these two tabs open here, one representing the host on either end of that data plane we showed, and here's my mininet command tool. So I'm really, what I'm going to do is just start up our ICMP traffic be going from one end to the other. So I'm going to start it in one tab, and I'm going to head it in one direction, and I'm going to start it in the other way. So we see I'm starting my ICMP traffic, and we can see that right now the data plane isn't doing anything because our services are not in place. So we'll come back to this later, but that's really our data plane started, and we'll just leave that for now. So we're going to drop into the control plane now at the ECORD level. I've got 3 tabs open here, so I'm going to be jumping around a little bit, just try to follow along. Right now we're in the ECORD level web GUI, and there's a couple things you need to kind of set up here at a system level. I'm going to go through those real quick. Really, the first thing you need to do is create 2 sites representing the cord locals that you're going to be working with. I've got my 2 sites here. You see them as cord 1 and cord 2. Okay, what else do we need to do? We also need to create these things called remote ports. And the remote ports really represent that kind of connective aspect I showed in the diagram earlier between, the Ethernet interfaces on those 2 different parts of the data plane. So it's the part where, the systems are connected together. So you need to tell the system about how things are connected. And that really represents, so we have 2 things here. Obviously there's a connective element between the ECORD and the cord local 1, and there's a connective element between the ECORD and the cord level 2, and that's what we have here. So the sites and the remote ports, we call them here, are things you don't set up very much, but I just thought I'd show them because, well, they are important, and you do need to set them up before you can do anything. But they just kind of do them once, they're very seldom. So remember, what we're trying to do is create our VnoD global, so let's go ahead and do that. First thing you need to do in doing that is create what are called service spokes. So the spokes represent effectively sort of a proxy object of what's going on in the cord local. So you need to create 2 of these because we have 2 of them in our system. So I'm going to call my first one our cord 1 spoke 1, that's fine. It's attached to cord 1 site, that's fine. I'm going to use that connective element that's facing the cord 1 system as I showed you quickly earlier, so I'm just going to create my first spoke. Okay, and then I'm going to create a second spoke to represent that second system, and I'm going to call it our cord 2 spoke 1, that's fine. It's going to be VnoD local cord 2, the site is cord 2, right, because I'm pointing at that other cord site now. I'm going to use now my second connective point that I've programmed into the system that's facing the cord 2. I'm going to create that. So it's really quite simple to create spokes, and I'm going to go and create my VnoD global. When I create my VnoD global, I'm going to drop into this form, and by the way, I'm doing this all with forms. There is kind of a map GUI that the ON Lab guys are working on. It's going to provide kind of a nicer way to do this with a way of visualizing it, but for now that's not ready. I'm just showing you in the forms. So we create this thing called a service handle, which is a globally unique identifier that's used at both the ECORD level and the cord local level to identify the service. So it could be anything, so I'm just giving it a test handle. We'll see it later. We also program in the VLAN that's going to get used by this service, so we'll just use VLAN 100, that's fine. And we'll say that here at the ECORD level, we're going to bind this all together with an E-line. We only have 2 sites, so E-line's fine. We could also use E-line as well, but let's just use E-line. And we're going to say that we have both of our spokes. I'm going to select both of them. There's a bandwidth profile here that I won't go into detail about, but we attach it. It just has, if you look into that, it would have some class settings about what kind of service kind of guarantees that are going to be attached to this E-line. So I'm going to go ahead and save this. So remember, go back. Now I've got my VnoD global in place. So I'm going to go jump back into my slides. If I can find them in the right spot here. There we go. So now I've done this. So really at the ECORD level, I've created my VnoD global. So, and really this is purely a control plane thing. There's nothing happened in the data plane yet. Really nothing happened at all. Really what we've just declared here is the intention to have a network at the control plane level in the ECORD. So now we need to progress along that path, and we're going to now start doing some things in the cord level 1. So out here in the 2 cord pods, I'm going to, there's a couple interactions we need to talk about. So The next step we need to do is create a thing called a Pseudowire service in the Cord 1 site. And what we're going to do with that, we're going to give it a service handle. It takes two things, a service handle. So that's that global service handle that we generated at the eCord level. So we need to use that service handle. And then we're going to provide it also a local source port. So this is the source port where the traffic is going to be originating. And that could be, well, based on this customer premise equipment sort of thing. What is the source port? So that's step 2. What's going to happen under the surface after you do that step is the Pseudowire service is going to create this thing called VnoD local, and it's going to pass that service handle to it. And the VnoD local, what it does is really provides kind of a gateway to the global service, and it's going to use the global service's REST API with that service handle, go and fetch some information. And it's going to principally push down the NNI information. So it's going to push down some of that connective stuff that we showed earlier, the connective elements of where to help the Pseudowire understand where it needs to push its bits to. So remember, it has a source port, and now through the VnoD local, it's going to be able to get a dest port effectively. And once it has that, you're going to move into step 5. The Pseudowire service can now, since it has 2 ports, also has the VLAN identifier, now it can push down to the network controller locally and actually get its Pseudowire set up. So it's going to get its Pseudowire set up from the source port to the dest port with that VLAN identifier. So we're going to see that drop down in the network controller, and now we're going to actually have bits flowing here at this level. So the source port to the dest port, there's going to be bits arriving, and it's going to be ready to go. The last thing I need to do, though, at the control plane level is to kind of signal to the VnoD local, again, to let the VnoD global know that from a control plane perspective, hey, those bits are flowing, it's ready to go from its intents and purposes, and that's the last thing that happens here at the Cord 1 site. Next step, I've kind of abbreviated all the different steps that happen at the Cord 2 sites are basically exactly the same as the Cord 1 ones. So you need to do all that stuff, and I want to just point out as well too that there's a slight difference here. When the VnoD local at the end of that sequence tells the VnoD global about the fact that, hey, I'm ready to go, I'm pushing bits to my NNI from my source port, it's going to be of a slightly different reaction at the global level, because when the first Cord 1 came up, which is the first element of our E line, what happens at the VnoD global level is it kind of effectively takes note. Okay, fine, I got one of my spokes is up. That's interesting. I know I'm expecting 2 because it's an E line. I'm going to wait. And now what's happening here in Cord 2 is the second part of that E line is going to come up, and now it's going to report to VnoD global. VnoD global is going to make a bit of a different determination now, because now it sees both endpoints are up, both spokes are up, and it knows that it needs to now go ahead and do its data plane work, and it's going to drop into its data plane and create that E line across the eCord, and effectively creating our end-to-end Pseudowire to E line to Pseudowire connectivity. Okay, so a slight difference there in what happens to the interaction of Cord 2, and that's worth talking about in the slides. And I'm going to leave the slides now and drop down into our command tool again and just pop into the real world. So let's do that in the real world. So we still see our data plane pinging away here as we started. Still nothing happening yet, because nothing's happening in the data plane. We just have a control plane concept at the VnoD global level. So I'm going to drop down into my Cord 1, and I've got 3 tabs here in my GUI, so I'm going to flip between them a little bit. Hopefully it's fairly clear. So I'm at the tab right now for our Cord 1, right? So I'm at the Cord 1 level, and we're going to do what I talked about earlier. We're going to create one of these things called the Pseudowire connectors. So it's going to create Pseudowire service at the Cord 1 level. So I'm going to give it our global service handle, test handle we configured earlier, and then we're going to give it our internal port. So this is an internal port where, as you remember from the network diagram earlier, our bits are going to be flowing to this port over the network. So this is just at this level, in the Cord 1 level, it's 1/4, and I'm going to indicate that I want an activation. And I'm going to drop this into the system. Okay, and now I'm going to go over it. So that's how working away in the Cord 1 level. All those interactions that we talked about are occurring. We can just sort of watch that a little bit if we want. I'm going to sort of pull this, refresh the form a little bit. And eventually this thing's going to drop into, you see the enabled state here, the administrative state. And effectively it's created its Pseudowire, it's got bits flowing to its interface, it's ready to go. It's also told the VnoD global, from a control plane perspective, it's ready to go. So now let's drop into the Cord 2 site and do basically the same thing on the other end. Okay, so this is my second spoke. I'm going to create another Pseudowire connector here and use my global service handle, and I'm going to give it my internal port, which represents where those bits are going to be flowing 1/2 in the cord 2 site, and I'm going to ask for an activation. Here we go. Okay, so VNOD, cord 2, I've created my Pseudowire connector, I've dropped it in the system. I'll refresh the form a couple of times and watch it do its work. Eventually the system will tell us about the fact that it's got its Pseudowire going, and you see that in the form coming up as state enabled, and the Pseudowire handle here is all that's in place. Okay, and out of our peripheral, we're going to see here that, lo and behold, our data plane here is now moving packets from one end to the other. Okay, so I've got packets pushing from one end of the data plane, and if I look at the other command tool, I'm flipping between them now, we see packets flowing backwards and forwards between those two hosts, the ICMP traffic across our network. Okay, so let's just review what happened here. Again, remember we're showing at the VNOD local levels, we're showing our Pseudowire connectors here. If I just drop up again into the tab at the global level, and if I look at our service here at the global level, here's our E-line service. Now I see our E-line service is in state enabled, and I see it's active. And if I also drop in to look at the spokes, let's look at the spokes. We also see their state is enabled. The spokes really kind of are proxy objects of what's going on in the cord sites, the two cord sites. So for them to be enabled is correct. They're reflecting the fact that, hey, the cord sites are pushing bits to those NNI points, and the E-line in the middle of the E-cord level is moving those bits across the arch of the network and creating an end-to-end composite network here. So let's just go back. We see bits flowing. That's all very exciting from a networking engineering perspective, and kind of visually unexciting, but hey, you got to be able to get your excitement in different ways in this kind of line of work. And whoop, here we are. So let's just zip back real fast before you end the demo to just say, where is it? Here we go, back to here. So that's what we just saw. Now we got this little crazy E-line squiggle, this orange squiggle here. We got the two Pseudowires in the end. We got our MEF E-line in the middle. We have ICMP traffic flowing end to end. So that's the end of the demo. Hope you got something out of that. And if you need to contact me, my email's at the front of the presentation. We'll talk to you soon. Bye-bye.